Well, hello Internet, and welcome to my Dart video tutorial. This is updated, and I am going to be dealing a lot with Flutter, specific parts of Dart, but the whole entire language is going to be here. And in the description, I have installation instructions, and I have a lot to do, so let's get into it. All right, so everything is going to work the same for Mac as well as Windows. You can see here I have Visual Studio. That's what I'm going to be programming Dart in. I'm going to be using Android Studio for Flutter, so why don't I show you where to get that. All right, so if you want to get Visual Studio Code, you just go to code.visualstudio.com and you can download it for all of the different operating systems, and the installation process is extremely easy. Then what you're going to want to do is you're going to want to go and get the Dart extension inside of Visual Studio Code. So actually, after you open up Visual Studio Code, just click on these little boxes over here that look like Tetris pieces and type in Dart. And then you're going to come over here and click on Install. And you're going to see a window like this. And everything is going to install for you and everything's going to work. Now, I'm going to be outputting everything to the debug console, as you can see right here, just to keep everything simple. And to get to that, you just find Preferences and then go to Settings. And if you want to make your font bigger, people ask me this all the time, just type in Debug Console up here in the search field. And you're going to see that Debug Console font size shows up, and you can change it to whatever you'd like. All right, so that's the setup process. Now let's start writing some code. All right, so the very first thing I'm going to do, I'm going to come over here and I am going to create a new folder for us to work with. So I'm just going to say File, and I am going to say Add Folder to Workspace, and I have something called Dart Tutorial. So I'm just going to select that and click on Add. Do I trust the authors of this file? The author is me, so yes. All right, so I have my folder here. I'm just going to select it, come up here, create a new file, and I'm just going to call this dtut.dart, like that. Hit enter, and here we are. You can close this down, and now we are ready to program with Dart. All right, very first thing, I'm going to import our math library. And to do so, you just go Dart and math like this and throw a semicolon at the end. That's going to provide a whole bunch of different formulas for us. And the reason why those squiggles are there is because I'm not using it. All right, so that's it. So let's get the obligatory type of stuff out of the way. How do we do hello world? Everybody wants to know. Well, void main is where the program is that you're going to execute all your code inside of. And you just say print, and let's be different. Let's say hello Dart instead. And all the code here is also available and heavily commented in the description. There you are. Have everything all set up right there. And if I run this over inside my console, I'm going to come down here where it says debug console. And here you can see it prints out hello Dart over in the side in the debug console. And you can just click on run right here to execute that if you'd like. All right, so we got hello world out of the way. There's a lot more to come. So basically, variables are going to either be dynamic, or meaning that you provide a value and it figures out what the variable type is or the data type is, or explicit, meaning that you actually tell it, hey, this is an integer, this is a string, this is a whatever. So in this situation, I'm going to have it be dynamic. I'm not going to define anything. So I'm just going to say name is Derek. And you can also come in and be explicit and say string name2 and still Derek. All right, so there we are. So you can either be dynamic or explicit. One thing to be aware of, however, is once the variable type is set, it is fixed. So for example, if you typed in name is equal to 2, that is going to cause an error because it is not an integer, it is a string and will remain a string. You are, however, going to be able to make what are called dynamic variables. So we're going to say anything here, but it is normally advised not to do this, but just to cover everything, you can now go in here and say anything is equal to and throw a string inside of it, even though it is originally a integer. All right, so something to be aware of there. Maybe you've decided that you would like to, let's get rid of this first, like to create a variable but initialize it, meaning give it a value at a later date. In that situation, you can just say late int and var1 like that. And there are two number types. There's integers, being numbers that do not have decimal places. And there are doubles, which are numbers that do have decimal places. There are Boolean data types, and so we can have can vote, and they can either have values of true or values of false. Let's say you would like to come in and find out what data type a variable actually is. Well, I'm just going to use print here like this, and I could say is bool like that. And this is string interpolation, which just means it provides a way for you to either put your variables or create calculations directly inside of your print statements. This guy right here does that, the $ and the two curly braces. And then we can come in here and say something like can vote is bool. And that is how we can check if that is a Boolean data type. And you can see that it comes back as true. There is no character type. And one thing that's important to know is variables can't be null unless you declare them as a nullable type. So to do that, you can say this is int, and I can just say something like I'm null, like that. And if we come in and say print like this, and I'm null like this, you can see indeed that it does get printed out as null. And another thing is if you would like to define a constant, you can do so. So let's say we wanted to have pi inside of here, 3.14, just to keep it simple. And there you go. That is how you define constants. All right, so after we talk about data types, it makes a lot of sense now to talk about casting. All right, so let's say we have a string here, and let's just call this snum is equal to and 45. And we would like to convert it into an integer. Well, we just say int I num is equal to, and then you go int and parse s num like that. And now you have an integer representation of the string 45. You can also convert integers into strings. So let's go and get snum is equal to, you can go I num by just calling toString like this, and that converts it back into a string. You can convert strings to doubles. So let's create a double. Let's call this dnum equal to, and you should say double and parse. So pretty easy to remember. Another thing to be aware of is if a value isn't valid, it's going to return a null. So let's go double, and remember with our question mark here for nullable values, dnum and 2 is equal to, and we could say double, and we could call try parse. Try parse is actually preferred to be used over just simple parse, and we could do something like 1.2 and then throw in a letter, okay? Obviously not good, and with Visual Studio Code, we can just select everything, put quotes around it like that, and everything's gonna work like that. And if we come in and just to verify that what I just told you is true, we will throw this like this and run it, and you can see, yes, indeed, it comes back with a null value. All right, so that is how we cast values, and now I want to talk about some math. All right, so I don't want to bore you with having you watch me type this in. Basically, we can perform addition, subtraction, multiplication, and division, and you can see exactly how all of those are going to execute, right like that. There's going to be a couple other additional math functions. We're also going to be able to perform integer division. And to do that, you just go tilde, which is in your upper left-hand corner of your screen, and tilde like that, and you get integer division. And you're also going to be able to find the modulus, or the remainder of a division. And if we run that, you see the output right there. Another thing that's useful is there is a shorthand way to increment and decrement. So let's say we have a variable right here. Move it up here so you can actually see it. Here is a variable, and we'll just call it n1 and give it a value of 5. Now, if we would come in, I think I still have print here. Yes, I do. All right, so if we would come in here, get rid of this part, and say n1 plus plus, we're going to increment this. And n1 plus plus, right like that. And then we would say this basically just means that we want to add 1 to the variable n1. All right, pretty simple. However, this causes a little bit of confusion. Let's say I come in here and I put the plus plus part. Let's cut that out of there, throw it right here, and again, throw this right here, and get rid of this. Now, what output are we to expect whenever we would run this? Well, what we get is 5. Well, you say, wait a minute. You said that whenever we put the 2 plus signs on there, that it's going to increment it. Not in this situation. When you put the plus signs after, or I should more specifically say this, what it's going to do is it's going to say, what's the current value of n1? Well, it's 5. Okay, print 5. Then after you print, add 1, which makes this 6. And then in this situation, the plus plus is first. This says first add 1 to the variable n1, and then print that out. And that is the reason why you get 5 and 7 here, which might not seem logical. Likewise, there is a decrement shorthand as well. So we can just throw these on here. These are postfix and prefix incrementers and decrementers, if you want the technical jargon for exactly what this stuff is. And we can run it, and you see here we get similar results. Now remember, whenever I went and imported this library up here, Dart Math, well, guess what? Dart has a ton of math functions. Here are the most common ones. So what I did was I created 2 variables, M2 and M3, gave them 2 different values, of course. And you can see here that we're able to find even values. Let's go and run this. You can see it side by side. All right, so we're able to find out if a value is even or not, if a value is odd or not. We can go, here I multiplied -1 times this variable to get a negative value to be able to get the absolute value, as you can see here. Ceiling is always going to round up to the next value, as you can see. Right here, it gets 4. Floor is always going to round down. And round is going to round depending upon this value. Since it's 4, it's going to round down. If it was 5, it would round up. Truncate is just going to knock off the 0.4 off of here as if it didn't exist. And you can see here we're able also to compare different variable values. And in a situation in which the values are equal, it's going to return 0 in the situation which the value on the left is, and by left I mean this, is greater than the value on the right. It's going to return a 1, and likewise if the left one is less than the right value, it's going to return a -1, as you can see it did right here. We're also going to be able to find the natural log, the minimum and maximum value of the 2 provided. We're going to have a power function, 3 to the power of 2, and also square root functions, and then a whole host of trig functions. So there you go, a roundup of the different math functions that are available. Another thing we like to do with math is to generate random values. Well, to do that, you just say random r1 is equal to new and random, like this. And then what we can do is just simply come in here and print, and I'll say random, like this. And then I'll take my r1 and I'll say next int, which means I want a new value. It's going to be a random value up to the value of 100, like that. And every time that I run it, it's going to give me a different value. See, here it's 18. If I run it again, you can see here that it's 79, and so forth and so on. Another thing is there are also some built-in constants inside of Dart. So let's just go and copy this guy, throw it in here like that. We are going to have E, and we'll throw this right here. And also we're going to have pi. And I think that is the gist of what is most important math-wise whenever it comes to programming with Dart. And there you can see are those values. All right, so there's a rundown of some math functions. Now I want to talk about some conditionals. All right, so with your conditional operators, you're going to have equals to, not equals to, greater than, less than, greater than or equal to, and less than or equal to. You're also going to have logical operators, which is going to be not. If you put that in front of a true, it'll turn into a false. If you put it in front of a false, it'll turn into a true. And allows us to combine different conditional statements, and or also does the same. So let me just give you some examples here, showing you at the same time how if, and else work. So let's say that we have an age. I'm going to say age is equal to 8, like that. And what we want to do is figure out what school this person should go to based off of their age. Well, if the if statements in Dart work like this. You say if age is less than 5, like that, and curly brackets, and then you define what happens in that situation. So if they're under 5, we are going to say that that person needs to stay home. All right, so there is if statements. Now we can also say else if, like this, and let's use our logical operators here as well as our conditional operators. So we can say if, and you have to use multiple parentheses here, age is greater than or equal to 5, and age is less than or equal to 6. Okay, so that is a way to combine those different conditionals. And in that specific situation, we're going to say that this person should go to kindergarten, like that. All right, so let's do some more. Let's say that we would like to be able to find out what grade a student should go to. Well, in that situation, again, we're going to say else if, and parentheses important, age greater than 6, and age is less than or equal to 17. Well, in that situation, we're going to come in here. Actually, this should be else if, like that, and get rid of this additional information here. And let's take this and throw it up on top. All right, good stuff. Okay, so we got that. Now in this situation, it's going to be a little bit more complicated. We're going to tab in here and say print, and we can go and perform calculations directly inside of here. So we're going to say grade, like this, and then we're going to say age minus 5 is how the math works, and we'll be able to figure that out. Then, by default, if none of these are true, we are just going to say print, and college is going to be our output in that situation. And if we run it, you see that grade 3 comes back as our answer. All right, so good stuff. Another way of performing different actions depending upon different conditions is switch. So with this one, what I'm going to do is I am going to say that there are going to be certain ingredients. And based off of the ingredients, I am going to define what the person should make for dinner. All right, so I'm going to say switch and ingredient. So what this is saying is if the value for ingredient is equal to either tomatoes or pasta, I'm going to tell them to make spaghetti. All right, so I'm going to say case, but how do I do that? Tomatoes or pasta, spaghetti. Well, if you want to have multiple conditions, you can say tomatoes, like this, put a colon, and then follow that up with case pasta, like this. And in that situation, in both situations actually, we are going to say that we want to output spaghetti, like that. All right. Then afterwards, you can type in break. And if you do that, it will jump out of the switch statement and then execute any code that is down inside of here. That's what break means. I don't want to continue searching for any of the other things that follow. Now we can say beans is something we have. And if they have beans, we're going to say that they should make burritos, like this. Okay. And what do we need here? We need another break statement. Now, in the situation in which none of these are true, let's say that we are going to recommend that something that's going to work for everybody, and I'm just going to simply say, drink some water for dinner. All right. So now what I can do is I can go and execute this, and you're going to see spaghetti comes back, even though I have tomatoes here. And likewise, if I type in pasta, that it is going to come back spaghetti again. All right. So there you go. There's some conditionals, if, else, as well as switch. And one more, let's talk about the ternary operator. Now, the way it works is it's going to assign different values based on conditional results. So let's do our can vote again. So I'm going to say can vote. The value of can vote is going to depend upon the age. So I'm going to say if the age is greater than or equal to 18, well, if it's true, it is going to assign the value of true to this variable. And after the colon, I'm going to define false to this variable. And it doesn't have to be true or false. This could equally be 1 and 0 or a string or anything else that you'd like it to be. All right, so there you go. Conditional statements. Now let's talk some more about strings. Now again, strings of course are just strings, or just letters and numbers and spaces and such in between double quotes. And I assume that you know that because Dart is normally not a first language people learn. Okay, so I'm going to say here, I am, and you're going to be able to use strings interpolation inside of regular old strings too, not just inside of print statements. So let's go and get age is equal to, and let's throw 45 inside of there. You can just go like this, put age inside of there like that, and that is going to work as well. All right, so let's go and create another one. Let's go and print this just so you can see what it looks like. All right, I am 45 comes in there. All right, so good stuff. What else would we like to do? Well, there's also multi-line strings. If you want to create one of those, then you can just go S2 is equal to, you're just going to put 3 quotes like that. And then you could say something like, I am multi-line, like that. And then follow that up with 3 quotes and write like that. So that's how we do multi-line strings. And of course, you could have the I be up inside of here as well. Whatever you'd like to do. Okay, what else can we do with strings? Well, we can get the first character in a string. So let's say we wanted to get that for S2. Let's do S1 in this situation. So S1, and to get the very first one, you put a 0 inside of there. They are 0 indexed, and that would give you that first character, which in this situation will be the letter I. You could also find the index where a string you're searching for first falls. So we could say S1 dot index of, and let's say we're looking for the word am inside of there. Well, there you go. That'll get that for you. You can concatenate or join strings. So we could say create var S3 is equal to, and put and I like cats like this, and then easily join them together by going S4 is equal to S1 plus S3. There we go. And we could print S4 as well. You can check if a string is empty or not. So let's go empty like this, and string interpolation again, and S4, and is empty like that. Close off your curly brackets. And also you're going to be able to find something is not empty. And that is, we're just going to put this right here, not empty. And it just depends on how you like to look at the world. If it's a empty or not empty world. All right, so there you go. And you can see how those both work, as well as everything else we've been talking about. We're also going to be able to get the length, and we can just copy this so I don't have to keep typing. All right, print that inside of there, and let's change this to length and S4, and just type in length, which is going to be very useful. And there are numerous different escape characters that you should be aware of. And here are the ones that are most common for you. New lines, tabs, how to escape different types of quotes. Let me give you an example here so it makes more sense. So you could say something like print, and let's say that you would like to be able to throw new lines and tabs inside of here. Well, you could do something like I and a new line and am like that, and a tab and multi-line like that. There you go. There you are. And you can see it prints out I with a new line, am, and a tab, and multi-line. All right, so that's what I mean by escape characters. And anytime you would want to use double quotes inside of a double quoted string, of course, just precede it with a backslash, and you will be able to do that. And likewise with everything else you see here. There's also the ability to use escape sequences in what are called raw strings. So we could come in like this, and you just put an R in front of it. And what that means is basically new lines, characters like this and this, are just going to be ignored. They're going to be treated like regular old strings. And you'll see an example later on in the tutorial where I show how working with raw strings is useful. So you could say something like new line like that and like that. And in this situation, you see that the new line character does print when it is a raw string. Just precede it with the letter R. And there are numerous other different functions here we can work with. So let's just copy that, throw that right there. And so let's say we would like to convert our strings to uppercase and lowercase. How can we do that? Let's just come in here like this and throw some quotes in like that and go S4. And you can just say to uppercase. And you might say, well, why would you ever want to convert everything to uppercase or lowercase? Well, very often, whenever you're working with strings, it's a lot easier to just convert the string that they send you that could have numerous uppercases, numerous lowercases, and make them all lowercase, then go and search for whatever you are looking for. All right? So that is in a situation in which changing to uppercase or lowercase makes a lot of sense. And if you want to check for lowercase or convert everything to lowercase, you just change this to lowercase, right, like that. And you can see here they're uppercase, here they're lowercase. Of course, there's no such thing as lowercase for numbers. Now, there's numerous different ways that we can check to see if a string is inside of a string. So what I'm going to do is I'm going to create a string here, and it's just going to be I am here, like that. And I'm going to close that off, get rid of this quote right here. And let's say that we want to check to see if it contains the word am. Well, you just come in and say contains and am, like that. And likewise, you're going to also be able to see if a string is going to start with a specific character. So let's just change this to starts with, like that. And we can throw letter I inside of there. And we're also going to be able to check if it ends with. So we'll just change this to ends with, like that. And then we'll throw here inside of here. And all these are going to come back as true in this situation, but of course, not true in the real world. All right, true, true, true. Okay, all of them are true, and you can see why they are true. You're also going to be able to get a substring. So let's come in here. And I am going to just use S4 in this situation. So I'll say S4 like that. And we are going to define the index where we want to start searching, which is 13, and up to but not including the last index we want to search for, like that. And you can see if we do that, we get LIK, and this is with our S4 string, which is, you can see, there's like. Now, if we want to get the full like with the E, we just change this to 18, like that, run it, and you can see that we got the space. That was the difference. So this is actually, should be 14 to 18, and if we do that, now we get exactly the word that we are looking for, based off of what we defined with our substring. Now let's go and let's say you would like to replace part of a string. So I'm going to create another one. It's going to be called S5. And this is going to be to, no, or not, to, no, like that. All right, and then we'll go var and S6. And it's going to be equal to whatever S5 is. And we're going to say that we want to replace all. And we're going to use what is called a regular expression. I'll talk more about those later. But this is a very simple way for you to just go regular expression like that, and specifically what you would like to search for, and then outside of those parentheses, what you want to replace the word no with, which is the word be. And then we can come down here and of course print out S6, and I think you know what it's going to be or not to be. All right, so that's how to replace strings. Now we're also going to be able to convert strings into an array. And in this situation, specifically what we want to do is we want to go and take this string and split it. Now you have to define how you want to define how the words are split. I'm going to say that all of the words in the string are going to have spaces between them. Okay, right like that. And then you're going to be able to say print AS4 like that. And you're going to see you converted your string into a list. Now in the situation in which you would have commas and spaces, of course, you could come in here and just put a comma and there's already a space, and that would work for you as well. So you can do anything you'd like as long as you have some definition there. Let's say that I would like to remove trailing as well as leading white space inside of a string. Well, we're going to be able to do that. So let's say I have just a bunch of spaces here. I have some words, and then I have some more spaces, and I'd like to get rid of those. So you just use trim. There we go, there we go. And if we run it, you can see that it comes back as stuff and got rid of all the white space. Now, one thing to be aware of is if you find yourself making regular changes to a string, it's very often better to use what's called a string buffer instead of a string, so you create numerous different strings. And how you create one is, let's just call this buff is equal to and string buffer like that. All right, so we can do something like, let's say I'm going to talk about for loops here in a minute, but they're so easy to figure out. You can say something like for and variable defined inside of our for loop. And then what we're going to do is just increment or add 1 to this value over and over again while I is less than 9. And then here is our increment function, right like that. There you go. Now you have a preview of the for statement, which is coming soon. And what we can do is if you want to add values to the string buffer, you just say write like that. And let's say we just want to keep it simple and we just want to add whatever the current value of I is. You can just do that like that and that like that. Okay? And the buffer is not, or the string isn't going to be created in this situation until we call toString on it. So just toString like that. And you can see provided a way for us to just go and add all of those different values onto or stick them in the string buffer and then print them out. And the string buffers have both a write function, as you saw right there. We can do it again just for the heck of it. So we can say write and 9. And you're also going to be able to write multiple values. So you can say buff and write all. There's write all right there. And we can go and throw what's called a list, which is what we're going to call next, just a list of different values. So we can throw like a 10, 11, and 12 inside of there. So that's how you add multiple values. And again, we can just go and call toString if you want to see all of those printed out there on our screen. So there we go. And there you can see are all the other additional values that we added. And of course, you're going to be able to go and get the length of it. So let's come in here like this. Let's get rid of this part right there. And we can say something like length, and we can go and get the length, which is going to be the same as what we did whenever we got the length for our strings. And also, it's important to know that you're able to use functions like is empty and is not empty, also just like we did with strings, along with other different functions that we have here. And there you can go, and you can see there is the length. All right, so there you go. That is a rundown of strings and string buffers, and now we're going to talk about lists. Now, Dart has generic containers for data where you can store multiple different values, and then assign them all to exactly the same variable name. So we're going to have a variable here, and I'm just going to call this L1 like that. And what you do here is we're going to define that this list is going to contain strings. And this is just an empty one right like that. You're also going to be able to go and assign values just by saying list like that and string like this and L2 is equal to. And we can go and put multiple values in at the same time. exactly like this. So let's go A like that and like this. Okay. You're also going to be able to create lists with multiple different types. This can cause confusion though, because these are just considered generic objects. But you can do it. You can say 1, 2, 3 and Maine like that, and Pittsburgh, for example. There you go, and there you are. Now you're going to be able to get indexes for these guys. So I am going to say that I want the first, or let's say we want to get to the whatever is number 1 index, all right, which is actually going to be the second in our list. We're going to be able to go like this, of course, $, curly brackets, and let's work with L3 in this situation, and 1. And can you guess which one is going to be output onto the screen? It is going to be main, because it is the second. Remember, this is going to be 0. All right, let's do more. Let's say we would like to make a list, and this is L4, and we want to define that we want 3 spaces inside of it, and we want everything to have a value of 0, and we want to define that this list can be increased in size. All right, well, we can do that just by saying list, and it's going to contain integers, and you can say filled, and 3 spaces, 0 in every one of those spaces, and growable, and set this for true, and it will be able to be increased in size. Now you can come in and also add values. So let's say we want to add C to our list of grades, this guy up here. We're also going to be able to add multiple different values by saying add all like this. And let's say, well, let's put a D inside of here and an F inside of here. And there you are. And we're going to be able to get length. Again, I'm sure you can probably guess how we're going to get the length. You just say length like that and like this. And we can go L2 and length and curly brackets, and that's going to get the length for our list. We can also come in and check if a list contains a specific value. So let's go and copy this guy right here, paste it inside of there, and let's just type in main, and let's say we want to find out if the list contains main. Let's change this to L3, and let's change this to contains like that, and main, and remember your quotes, and that is going to tell us if main exists in that list or not. You're also going to be able to sort lists just by calling sort, and what this is going to do is it's going to say take the first item in the list and compare it to the next item in the list like that. A dot compare to B, and it's going to compare each value one after another until they have all been sorted. And also, we're going to be able to print these lists. I showed you before how to do it. You can say variable value. That value is going to be the temporary holding cell for the list that we are cycling through, which is list L2. And what we want to do here is we want to cycle through each of those items, assign the value to the variable name val, and then we want to print out all of those values. And we can do that like that, and here you can see the output for everything. And you can also see that everything has been sorted for us because we told it we wanted it sorted. We're going to also, let's say we would like to find the index for the letter F. Well, I can call this F index is equal to L and 2. Just call index of, and we're specifically looking for F. Now we can use that information to specifically remove that index by going remove like that and remove at specifically, and it's going to be the index where F was found. And then we can also, of course, clear our lists, which means delete all of the data inside of them. All right. And if we run that, you can see, well, nothing changed because we just removed values and cleared them. So, of course, nothing's going to change. Another thing that is very useful is, let's say we would like to generate a random list of values, something I do a lot. Well, let's just go and create a random function here or a random variable and just go random like this. And there you go. And we can say that we want to create list 5. So this is going to be list, and it's going to have integers inside of it. And then we can go and call generate and 5 and int, and this will be index like this. And then put this little arrow symbol and call R2 and next int like that. And let's get random values up to 100 like that. And there we go. And then we will be able to come in here once again and cycle through and print out these random values. So we're going to create 5 random values that are going to be integers. All right, so we want to print them out. Again, val in L5 like this, and print and call that we want the value to be printed. And we can run this, and every single time we do, we're going to get 5 new random values. Another thing is we're going to be able to get the first as well as the last value. So throw this inside of here like this, and L5, and we can get first like this. And of course, I'm guessing you can probably guess how we're going to get the last one. Yes, indeed, you are probably correct if you said change this to the word last. And there you are, and there you go. All right, good stuff. We can also create what is called a iterable with a range of different values. So iterable like this, and int like that. Let's call this I1, and we can go and get L5 and get range like that. So let's say we want to cycle through the 0 through the second index. We can do so. And let's just go and copy this right here and paste it down inside of here. And then we'll just change this into I1, and everything else here is exactly the same. And there we go. And you can see that we printed out 58 and 25. And then finally, I'll show you how to convert a list into a string. So let's go and create a string S7, which is, we're going to call the list L5, and we're going to say that we want to join these items, and we want to put a space between all of them in our new string, and then we can go and print out our new string exactly like that, and there they are. All right, so there you go. Example of strings, and I've been talking about looping, so now I'm going to cover it fully. All right, got some coffee. Let's talk about looping. All right, so we already talked about for loops, but let me review it. So you define a variable. There you are, like that, just like we do outside of a looping structure. And as long as I is less than, let's go and create ourselves a list. There you go, throw this in here. Just generate this list just like we did previously. And let's go and do random R2 dot equal to new random like that. And there we are. Okay, so we can say, while I is less than the length of this list, we want to continue looping. Okay, and of course we have to increment the value of I each way through. And then we can come in and we can print all of the individual indexes inside of this list. All right, exactly like we talked about previously. And there are our random values. Now, you're also going to have for each. And you're mainly going to use for each anytime you don't care about the index. So if you don't care about the index, well, who cares? Let's just cycle through it. So we're going to use for each, much easier to use. Define our value that we want to assign to each individual part of the list as they come out of the list. And go like this, and boom, there you go. And you're going to be able to also cycle through and print all of your list items that way. Also, you're going to be able to perform different calculations So let's go and do, well, let's just use our for each we have here. So as we cycle through each of these, let's say we want to multiply these values times, say, 20. You can do that, perform any other calculations, and you can see there is the results there as well. And if you're wondering why you didn't see the results previously, it was because it was the same list put in twice. Here, let me actually go back and show it to you so it doesn't cause any confusion. So let's save it. And see the 2 here? That just means that this was printed 2 times. All right, so just didn't want you to get confused there if you saw that and were wondering what was going on. Let's also come in and let's create a string. And it's going to have some words on it. So Bob and Sue and Tom. Right like that. And let's say we want to split this and print each word in a string. We can say for var and person in str1 and call split, and we want to use the space specifically to define where each individual piece is going to be found. And then we can just come in here and go person like that and go and execute it. And another way to cycle through here and print out this information. Now a while loop is going to work slightly different. You're mainly going to use while loops whenever you don't know how many times you want to execute code. So I'm going to create a variable here, and I'll call it I2 and give it a value of 1. And what I want to do in this situation is I want to define that I want to continue executing code as long as I2 is less than 10. But then what I want to do is I want to say that I want to print only odd numbers. And on top of that, I want to stop at the number 7. So how would I do that? Well, I'm going to say if I2 modulus 2 is equal to 0. Well, in this situation, we know that if the remainder of a division with 2 is 0, that means it's an even value. So I'm going to say, well, I don't want to print that. Instead, I want to increment the value for I2. And then I want to jump back up here and continue now with a new version or a new value inside of I2. How do I do that? I just say continue, jumps back up to the top of the loop and continues executing. Except now, let's say I2 starts off with a value of 1. Well, actually, it wouldn't work that way. It would be a value of 2. Then it would come down here. It would now have a value of 3. It would jump back up here and continue checking. All right, so that's what continue does for you. Now, I also said I want to print if I2 is equal to an odd value, but I also said I want to jump completely out of the looping anytime I2 equals 7. So I'm just going to put in another conditional and say break. Now, if we get down here, we know that it is an odd number, and on top of that, it's not 7. So we can print it, but don't forget to increment the value of I2. And we will do that right like this. And if we save this and run it, you're going to see that it went and printed 1, 3, and 5, exactly like we wanted it to do. All right, what else can we do? Well, there's also a do while loop. And you're going to use those anytime you want to guarantee you execute at least once through your code. And what I'm going to do is I'm going to come up here and use our random object that we have up inside of here. And I'm going to create a lucky number and then create the simulation of a guessing game. So I'm going to say that lucky is going to be equal to R2 and next int and 10. Right like this. And I'm going to make this var lucky. So there is our random value that we're going to try to guess. And I'm going to start off guessing at -1. And let's spell guess correctly. There we go. And then I'm going to do my do while loop. So I'm going to say do like this. And I'm going to go and get the value for guess and increment it. And then I'm going to say print, and just so we can track what's going on, the guess in this situation is going to slowly increment up. Yes, I know I can get this result a lot quicker by jumping into the center of the list, but I'm just doing this to demonstrate the do while loop. All right, and that's it. And then what we do afterwards is we put our condition down here that we're going to check after we have executed it once. So we're going to say we want to continue looping as long as Lucky is not equal to the value of guess. And then also what we know is if we get through this do while loop, well, that means we found it. So we can just jump down here like this and print and say Lucky is like this, Lucky is, and then put in the value of Lucky, meaning that we were able to find it. And if we execute, you're going to see that it guessed the whole way up to 8, found out that Lucky was 8, and we can continue executing. That time it was 0, and this time it was 5. And there you go. There's multiple different ways to loop. And now I want to talk about map collections. All right, so basically a map is just going to be a collection of key value pairs. So as you're going to see, I'm going to do superheroes. I'm going to have the key be Superman and the value associated with that key be Clark Kent, okay? And they can grow as well as shrink. How you declare an empty map is you need to define what types of data are going to be inside of them. So I can say that I want a string for my key and an integer for my value equal to new map. And then you have to put in the same thing, string and int, exactly like that. And there you go. You just created an empty map. So let's go and declare one and initialize it. We can also go and let's say we want to go heroes like this is equal to, and inside of curly brackets, we're going to define our key, which is going to be Superman. Follow that up with a colon, and then put in Clark Kent. There you go. And, sorry Superman, gave away your secret identity. Then you can have Batman, key, and a key is just like an index with lists. And Bruce Wayne, right like that. There you go. You created a map. Now, what else can we do? Well, we can add another hero in here if we would like to. So we'll say heroes and Flash is the key, and it is going to contain a value of Barry Allen. So there that is. What else can we do? Well, we can check to see if our map is empty or not just by coming in here like this and going inside of curly brackets, heroes is empty, and of course we can do is not empty just like we did previously. You can go and play around with things like this. There we are, curly brackets, and test out the other functions like is not empty. We can get our length. Might as well just copy this, paste it inside of there to save some time. Paste that there and put length inside of here. There is length, and if we want to get the hero's length, guess what? We just type in length. There it is. What else can we do? Well, we can print our keys, and I'm going to use for each to do that. So we have heroes, and I'm going to say keys is what I want to print, and for each. And we can do value inside of here like that, and a little arrow, and go and print that value out. There we go. We can also print out just the values. So come down here, change this to values like that, and guess what? That's going to work. And we can run all this. Whoops, I have an error. What'd I do? Oh, I spelled values wrong. There you go. And if you ever get this, just come up here and go to debug console. And there you go. And you can see we printed out the keys and the values associated with those keys. What else can we do? Well, let's say that we would like to add multiple different values. So let's say that some villains decided to come in and join the heroes for something. So we'll say heroes, add all, and like this. And we'll say Lex Luthor became a hero. And what's his? Well, that's Lex Luthor. Not very creative, is it? And we can come in also and get Loki. And Loki's secret identity is there. All right, and that will add both of those as well. Well, then maybe we find out that Lex Luthor wasn't being honest after all. So we're going to say, hey, we want to remove Lex Luthor from the hero list. He's a bad guy. And there, that's taken out. And what else? We can also come in and do heroes and clear to get rid of everything. And we can come up here. Where's the empty thing at? There it is. We can go and copy this just to verify that everything has been deleted. Save, boom, boom. And there you can see, yes, indeed, it is empty. All right. And that is the basics of what you need to know about maps. And now I want to talk about enumerated types. All right, so enumerated types contain lists of constants with an index. And you're going to have to define it outside of main. And you just type in enum like that, and day. And then let's just go and define some days of the week. So there those are. And there's Thursday, and there's Friday. There you go. You just defined it. And we don't put a semicolon at the end there. Now, down inside of main, I'll leave that on there so you can see it, because we have plenty of room. I can come down here inside of main now and define my favorite day. And that day would be equal to Friday. So there we are. And this is an uppercase. Make sure everything's case sensitive inside of Dart. Now I can come in and say print and a value and favorite day like that. Semicolon at the end. And I can go and also print out the index and like this and favorite day dot index. And there we are, like that. And the one thing that's cool about enumerated types, whoops, got an error. What was my error? Oh, I accidentally got rid of this last curly bracket. Just say cancel, throw that there, curly bracket. There we are, now it's fine, run it. And there you can see how it printed that out. And what's really cool about enumerated types is by using enumerated types, we can guarantee that we will only receive one of the specified options, for example, sent to our functions. And that's just going to eliminate very often the need to use if statements and other conditionals, which is extremely useful. All right, and so there's enumerated types. Now let's talk about ruins. All right, so basically a ruin is an integer that represents a Unicode and Unicode represents all letters, numbers, symbols, and everything. So you can see here an example of that, and here is Wikipedia. If you just type in list of Unicode characters like that inside of Wikipedia, you will see these, and this is Unicodes. And this specific number right here is going to be what we're going to be dealing with. All right, so all of the Unicode symbols. Well, actually, there's a whole bunch more. All right, so there you go. And basically, a ruin is just that integer value that represents all the characters. So what we can do here is let's assign and print a Unicode to start off. So I'm going to go number 1 is equal to, and backslash, this is Unicode 0031. Right like that, and I just showed you where to get the Unicode list. So there you got that. And now if I come in and print number 1 like that and run it, you can see it prints out the number 1 whenever I provide that Unicode for number 1. You can also get the Unicode. So let's say I'm going to go and create a string here. Let's call this UC1 is equal to strange like that. And let's say I would like to get the Unicode of a specific letter. How can I do that? Well, I'm going to print this out, and I'm going to say that I want the Unicode for the letter T in strange. So, got that right there. And how I specifically target it is I just provide the variable name, and then I say code unit at, and I want the second one, and this is 0 index, so that means that's going to be 1. Right like that. And there we go. So that's how we can get the Unicode for T. We can get all the Unicodes for all of these. So we can go UC1 like this. And I will say code units like that. And if we run this, you're going to see there's all of them inside of a list. And you can see 116 matches up with the T that's right there. And we're also going to be able to iterate through these. And you can just go ruins for each and int r1 and like this, and then just go variable C1 is equal to new string from character code R1, and then print out C1 like that. And then throw a semicolon at the end here. And if we run it, you can see that there we went and got all of them. All right. So quick rundown just to some examples of runes and how they can be used. And now I want to talk about functions. All right, so you're going to define your functions outside of main once again. I'm going to create a basic function. It's going to return an integer. It's going to be called getSum. It is going to receive two parameters. I'm going to call them n1 and n2. You don't need to define the type. And then it's going to take those two values, add them, and return them. All right, and that's how getSum is going to work. Let's go and make a couple other different getSums. All right, so let's go and create getSum, and let's just call this getSum2. You're also going to be able to come in here and define default values. So let's go and get into, and let's say that we would like it to have a default value, whoops, I accidentally deleted it, of 0. There you go. Now it has a default value of 0. Let's say also that we'd like to dramatically simplify this function. We can also do that. So we could also go get sum, and let's call this 3. It also receives n1 and n2, and we can just use this arrow function right here to just go n1 plus n2. And you're going to see that all three of these are going to work in pretty much the same way. All right, so let's create some functions here. I'm going to create some functions that just basically do the same type of thing, and that is add values. I'm going to create a bunch of functions, though, that do other things. All right, so this returns an integer. That's what that means. It's named getSum and n1, n2, like this. And what it does is it receives the parameter n1 and n2. They're going to have values. It's going to take both of them, and it's going to add both of them and return it. And this return value is going to be an integer. All right, let's create another type of getSum, though. So let's go down here, paste that in there, and let's just call this getSum2. We're also going to be able to come in here and give parameters default values, just like that. And there it is, default value. Another thing that's cool is there is a simplified way using the arrow function of doing exactly the same thing. Let's call this getSum3. Again, receives two different parameters inside of here, and it is going to return them, n1 plus n2. And there you go. Sometimes you won't be able to do this because it's complicated. But other than that, everything else is going to work perfectly. Now let's come down inside of main, and I will call these functions. So I'm going to say print, and I'll just say 5 plus 4 is equal to, and go and call the first getSum and pass it values of 5 and 4, right like that. Throw a semicolon on the end, and there you go. And of course, you're going to be able to do the same with getSum2, but also you'll have the added benefit that if you don't provide a value, it's still going to work. So let's just leave this as 5, and you'll see that it also works. And throw this inside of here. Another thing you can do is come in and override that default value just by going n2 like this and throw 4 inside of it as well. And of course, make this getSum2. There we are. And getSum3 is going to work in exactly the same way. But let's throw it in here and test it just to verify. So there's getSum3. There we are. Run them, and all of them are going to give you the results that you were expecting. But maybe you would like to be able to receive a list of values passed inside here. How do you do that? Well, I'm going to go and create another one. I'll call this getSum4, and it's going to receive a list. There you go, just like that. And now you can pass as many values in as you could possibly want, and it's automatically going to work. So all we need to do here is go return vals, and there's an awesome function called reduce, and it's going to take each value as it cycles through, putting their value inside of A and B, and you can cycle through them and add them. There you go, like that, and there you go. So there, that is how to receive a list of values. What else would you like to do? Maybe you'd like to return multiple values. Well, it's going to return a list. So let's say we want to get past a value and past the next two numbers. So if you get a 1, it's going to return a 2 and a 3. Well, receives a value and like this. And then you just simply create a list and return said list. Plus 1 like that, and n1 plus 2 like that. And both of those are going to work. All right, so if we come down inside of here, we can grab this and copy it and test out these new functions. So I'm going to say that I want to get the sum this time of multiple different values. I'm going to use getSum4, and I'm going to pass a list of values inside of it. So like this, now it's a list, 1, 2, and 3, and it's automatically going to work. What else can we do? Well, I'm going to be able to receive a list. One way to do that, I'm going to call next to, and I'm going to pass 4 to our function we created. And then I'm going to call for each, take all the values that were passed back, and then I am going to cycle through and print all of the values that were passed back. So like this and like this. There's an extra parenthesis that slipped in there somehow. And one that was missing back here. There we go. And don't forget your little arrow function inside of there. And if we go and we run that, you're going to see that those worked as well. All right, so pretty cool stuff. All right, so now I'm going to show you how to make a function that returns a custom function. So what we're going to do is we are going to say function, and I am going to call this mult by. What it's going to do is it is going to receive a value, and let's just call this n1, and it is going to create a custom function. Oh, by the way, might as well do something else. Let's create an inner function. So this is a function inside of another function. So here that is, and it has a value. And what it's going to do is return that value times the value that was passed in right here. All right, so pretty cool stuff. And then we can just say return inner function like that. But we don't want this part on here like that. All right, so what it's going to do is it's going to create a custom multiplying function. N1 is going to represent what this function that we're creating is going to multiply the value x passed into it by. So probably better just to look at it running, and then it'll totally make sense. So let's come down inside of here, and I'm going to say print like this, and 3, which is the number I want my custom function to multiply values times, and the value I'm going to multiply it by is 5. So got this right here, and then I'm going to go and call it. So mult by, like that, pass the 3, which is what it's going to multiply times, and a 5, which is what it's going to multiply 3 times. All right, so right like that, and if we run it, you can see it gets the 3, multiplies it times the 5, and gives us 15. So cool stuff. Now, we've talked about anonymous functions previously, but let's make another one. All right, so this anonymous function is going to tell us if a number is even or not. It's going to return a Boolean and function, and you just type in int. See, it doesn't have a name. Function is what's inside of there. So it receives an integer and is even, like that, is equal to, and int x. And what it's going to do now with that x that is passed inside of it, or that parameter named x, is it's going to use the modulus symbol 2 and see if it is 0 and return true or false based off of the result. And the cool thing is you can go and create these anonymous functions down inside of main. So let's just jump down here and do that. So right like this, there you are, anonymous function. And we can just go in and do something like print and say 202, is it even or not? I think you know the answer to that, but why not? We just do it this way. So we'll call is even and 202 like that, like this, close that off, and like that. Whoops, it's is even like that. run it, and you can see it comes back as true. And let's do one more function here. Let's also do what is called a recursive function, which is a function that calls itself. So we are going to come in here and calculate Fibonacci numbers. So I'm just going to call this fib. It receives an integer. I'm going to call it n1. And it's going to say if the value of n1 is less than or equal to 1, well, in that situation, we will return a value of 1. You always need a situation or a condition that is not going to call the function for a recursive function to work. All right? And else, in other situations, we are going to call the fib function, and we're just going to pass in a decrementing value of n1 plus, and again, Fibonacci, I'll explain how this works here to be precise, and minus 2, exactly like that, and exactly like that, except make this fib. There you go. And the way this is going to work, this is a recursive function, is let's say we pass 4 inside of it. Well, as you can see down here, we're then going to be calling it using 3, as well as down here with a 2. All right? And of course, whenever it receives a 3, it's going to convert that to 2 and 1. And then fib2 is going to add 1 plus 1, because that's what fib1 is, give us a final result of 2. This 2 right here is going to jump right there. The 1, of course, is going to jump right there because this returns a 1. Then this is going to be 3. That 3 goes here. Then we add 2 to it from this down here. And that is how we get our final value using a recursive function. So let's come down here and let's execute it. So we can just come down and we could say print and fib4 like that. And then come in and call our recursive function, pass in the value of 4, close that off, right like that, run it, and you can see that we get a value of 5. And that's how recursive functions work, as well as calculating Fibonacci numbers. And this brings us to type definitions. So let's get rid of all of that other information right there. And basically what makes a type definition cool is it is used to reference a function by defining a signature, basically the way the function is going to work with specific parameters. And we want functions to match. And what you could do is assign them to a specific type definition type. All right? And you're going to be able to change its value. And like always, it's probably better just to see an example to see exactly what's going on. So what we want to do is we want to define a type definition. And how you do that, you go type definition, and we're going to call this do math. And what we're going to say we're looking for is a function that receives 2 integers, n1 and n2, like that. And nothing is going to be returned. And what's good about this is it can be pointed at any function that receives 2 integers. And another thing that's cool is type definition can also be passed as a parameter to functions as well. So let's go and create 2 different functions here. So I'm going to create add, and it's going to receive an integer and another integer, right like this. And it's going to simply print out the value of n, like this, plus, and the value of n2. And then inside of here, it's going to add both of those together, right like that, and print it out on the screen. Now we can do the same thing with a subtraction function, just for simplicity's sakes. Let's make this called sub, and then let's just change this to negative and change this to negative. All right, so now let's look at the power this provides us. We can now, down inside of main, go do math like this, and let's call this math function, and we can say that it's equal to add in this situation. And now we can change the functionality of this function on the fly, right like this. All right, just that simple. Before we execute it, let's do another one. Let's just go and point at the other function now. Equal to, and this is going to subtract. and we'll do exactly the same call, and it's going to call totally different functions, which is neat. And there you go. That is how you get your different values. And of course, it looks a little bit nicer if we throw equal signs inside of here. So let's do that, and let's run it, and there you are. Okay, so there's an example using type definitions. And whenever I get into Flutter, I'll provide even more real-world situations in which you can use this to benefit yourself. But moving right along, let's talk about classes as well as objects and inheritance and all that. So a class, like you're probably aware, is just a blueprint for creating objects. So let's say I want to model a shape. What we must ask ourselves is, what does a shape have? Well, a shape is going to have a height. Give it a value of 0 by default. What else is a shape probably going to have? Well, it's probably going to have a width. Let's give that another value. Maybe it also has a unit, because what is a measurement if it doesn't have a unit? It's kind of worthless, isn't it now? So let's say this is centimeters. Okay, that's what it is by default. What else can we do? Well, let's get the space out of here. We can also define a value that belongs to the class. So what would be a situation in which we'd want to do that? Well, let's say every single time we make a shape, we want to monitor that shape. So if we make 10 shapes, we want to be able to call this and know that it's 10. This, being static, means that this variable right here, whenever the value changes for one object of type shape, it's going to change for all of them. It is going to be the same always. All right, so we're going to put that inside of there as well. One thing we're going to need to do is we're going to need to set up our shapes whenever we create them. To do that, we use something called a constructor, and you can recognize them because they have the exact same name as your class. And you're going to have a default constructor, which in this situation is just going to keep things as default values. This is a way for us to refer to the object that we don't have a name for. Because we create the class before we create the object, we don't know what the object's name is. An easy way to refer to an object is to use the word this. All right? And we'll have this height, and we'll have this width, and define all of these values. And what else do we want? Well, we want to monitor the shapes. We just created a new shape, so we want to monitor that. Well, how do we go and set the value? This is static, and it belongs to the class. We refer to the class name, followed with number of shapes, and increment it. There we are. We created an object. All right, what else do we want to do? Well, there are situations in which we would like to set the value for shapes whenever we create them. And to do that, in Dart, you use something a little bit different, and what it is called is a named constructor. So let's say I only receive one value, and I'm just going to go and copy this. So copy that, paste this inside of here, right like that. We can't just use shape and a different number of parameters. That doesn't work. You can come in and say we receive a length. Well, what we need to do is, this is called a named constructor. And you're going to specifically call the from-length version of this right here. And in this situation, both the height and the width are going to be equal to whatever the length is. Everything else, exactly the same. Let's create another named constructor. And this one is going to receive a height and width. So in this situation, we'll change this from length to width and height, like that. And we'll say that we get a double inside of here, which is the height, and another double inside of here, which is the width. There we are. And then what we can do is go and get the height, paste it inside of here, and we can get the width. And let's just go width like that. Everything else exactly the same. Another thing we have inside of classes is getters. And they are used to return data in a descriptive way. Let's say, like for example, we said width and height don't matter if we don't know what the unit is. Centimeters like that. So our getter is going to provide, it's going to tack on the centimeters. And maybe we changed the unit for this. And that's how we can go and get more detailed information. So we can protect the data, but also provide the information in new ways. So we're going to say shape height in this situation is a getter, and it's defined as a getter because we have get right there. And we're going to say return the height and to string, like this, like that, and then we're going to add on a space inside of here and then tack on the unit afterwards. So that is a awesome way of providing additional information. And here's another one, and this is going to be the shape width, like that, and we'll just change this to width, and everything else is exactly the same. Now, if we have a getter to make sure we get custom information in regards to our data, there's another thing that is called a setter. And what we want to do with this is we want to use it to protect our data. So one thing we might want to do is check if a string is a number. Well, let's create a custom function that does that. And it's going to be static. Why is that? Well, shape, the concept of is a shape a number doesn't really make any sense. Sort of sounds like a utility function, very much like the number of shapes was a utility thing. And in that situation, anytime you have something that doesn't directly apply to an object, probably means it should be static. So I'm going to say is number and string s. So it's going to get a string and tell you if it's a number or not. Let's go and close that up right there. And how do we do this? Well, it's very simple. We just say return and double and try parse like this. And as I said before, try parse, and if it doesn't work, we get a value of null assigned when we use try parse versus parse. And then all we have to do is go and check to see if this is null. So let's create our setter, which is what we were going to do before. So we'll say void set a value for shape height, and it is going to receive a string, which is going to be represented with the letter H. I'm going to say if is number, like that, pass in the H right like that, and if it is a number, well, we're going to say that's cool, we can assign it. So a setter is here to protect our data, and we can say double parse H to convert it into a double, and we know that's going to work. And we can also protect our width in pretty much exactly the same way. So let's just change this to width, width, like that, is number, and it's going to get W, and this is going to be W, and this is going to be width, like that, and this is going to be W. There you go, getters and setters. What else would we like to do? Well, we would maybe want to get the area for our shape. So we're going to say double area, and how do we do this? Well, we stay here on this line first, and then we are just going to simply multiply them together. So I'm going to say width times height, and that is the area of our shape. And there you go. Now we can come down inside of main and test this out. So let's create a shape. Let's call it sq1 equal to, and this is how we create a shape with a just default constructor, right like that. And we'll go and create other different shapes. Let's call this sq2. And what we're going to do here is we're going to use the named constructor from length. So from length, right like this. And maybe we'll put a value of 3.0 inside of there. And then we will use the other named constructor to create another different shape. And again, this is going to be from, and what did I even call it? Did I call it WH? From WH. So let's just copy this. All right, from WH, come down inside of here, from WH like that. And then maybe we will throw inside of here 3.0 and 4.0, right like that. So there we went and created multiple different shapes. And we can come in and say print square 3 area like that, and call and get it. sq3 and area, and it's going to be able to come in and calculate that and output it on our screen. So interesting stuff. And if we go and run it, you're going to see it gets the area. All right, that brings us to the concept of what is called inheritance. Now let's say we want to create a new thing that is almost exactly like a shape, but it's a circle. All right, well, circle areas aren't calculated by width and height. So how do we go in, make a thing that's going to get all of these awesome functions and constructors and all this awesome stuff, but at the same time work as a circle? Well, we use something called inheritance, and we will inherit every single function, every single variable from the shape class. How you do that? You just say class and circle and extends shape. So we're going to get all that stuff. And then if you want to override the area function because it doesn't work with a circle, you can do that. All you need to do is go override like that and define your own custom area right like that. Whoops, override. Accidentally hit the wrong thing here. So get rid of this. Override right like that. Okay. There we go. And this custom circle area, right like this, is going to say if this width, see, we're going to have access to all of those variables. So in a situation in which width is equal to 0, we're going to return pi, which is a constant, times the power of this width divided by 2 and to the power of 2. Okay, so there's that. And else, and this is very, very similar, so I'm going to copy this. I'm going to say else if, and in this situation, height, like that, is not equal to 0. Well, then we're going to multiply. We're going to use height instead. So, right like that. And then otherwise, else, like this, we are going to return 0. So, return 0. And there you go. There is our custom area function. Now, one thing that would be beneficial is for us to go and execute all of the functions that are inside of the shape class. How do we do that? Well, one thing we can do is, let's say we wanted to actually use the shape version of area. We can do it. Well, yes, let's just put it like this. You would just call inside of your functions, inside of your class, you could just say super like this and area, and it would go and execute the super version of area or the shape version of area. Okay? Another thing that is very useful is to be able to use the superclass constructors to set everything. Also very easy. So rather than type all those out, we can just say circle like this and call the super version right like that. And we can also go circle and from length with our named constructor, and it receives a W. I'm going to give it a value of L, and let's call the super version of from length like this and pass in L, and it will just handle it for us. And we have one more here. If we have the width and the height, and again, W is going to be H, and W, or double, is going to be double here. And again, call the super version and from WH and pass in the width and the height. And there you go. That calls the shape version of our constructor and gets all the benefits there as well. So really awesome. Now we can come down inside of here and we can define a circle. So I'm going to say circle, and I'm just going to call it circ is equal to new and circle from length like that. Pass in 4. There you are. And then we can come in and say print circle area like that. And go and call our new circle area function like this and like that. And you can play around with the other functions that I have inside of there, like the number of shapes and things like that on your own. Whoops, what's this? Don't know why that popped in there. Let's just get rid of it. Okay, so there it is. Let's go and let's run it. And there you can see we were able to get our areas circle. So pretty neat stuff right there. And that brings us to the concept of interfaces. All right, so basically you can only ever extend one class. However, you can go and implement multiple different interfaces. And what an interface is, it's basically like a contract. And what it says is that if you implement it, you must implement all defined functions in the interface. So let's create one. And it's just a class, just like anything else. So let's say we're trying to model some type of printer that is going to be able to print a laser, print as well as, let's go laser, like that. This is a function that must be implemented if you implement the print laser class. And also, let's go down here, and let's say it also prints to an inkjet. So we can go inkjet and come down here and just change this to inkjet as well. There you go. Well, now what we can do is we can define a basic print function that is going to implement both of these capabilities. So implements both print laser as well as print inkjet. And print and inkjet. Inkjet. All right, so there they are. And then, of course, what you need to do is go in and implement those functions. So I'll just say void, and it doesn't matter what you do in this situation, just keeping it rather simple. Whenever I get into Flutter, I'll get more into interfaces. But for now, I think this is enough to understand the basic concepts of what is going on here. And then we'll just call this inkjet. Exactly the same. See, print inkjet, print inkjet, and print laser, right like that. And there we are. Basic concept of interfaces, which I'll get more into if this video gets views and whenever I cover Flutter. Another collection type that we have available to us is what is called a set. And a set is just a collection of objects. However, they must all be unique. So it's just like similar to a list like we covered before, and kind of similar to a map, except maps, if you remember, are key value pairs. And basically, this is how you create a set, and you want to add a value to it. That's how you add a value to the set, and you can go and add another value to it. Let's say that we want to add 13 for some reason. You're also going to be able to add multiple different values at once. So let's create another set like this, equal to new and set like that, from, and just throw a list inside, and it's cool with that. It can work like that. And there you are. And you're going to be able to cycle, and you're also going to be able to clear the set using exactly the same functions as we have used with other collections. So there's that. And if we want to cycle, just so you can see what it looks like whenever we run this, there you go, and there you go, and there's a set. All right, so sets, just wanted to cover them, just to cover more of the Dart programming language. And now to finish up this rather large tutorial, I want to talk about exception handling. So what we're going to do here is basically exception handling provides a way for you to catch errors and handle them gracefully so that they don't completely crash your entire program. So I'm going to use an example here of trying to divide by 0. How you define them is any problematic code you're going to put inside of what's called a try block. Try, 2 curly braces, you put your potential error causing code inside of here. So I'm going to say print like this, and I'm going to say 0 divide like that. And then inside of here, I can go and get enum and try to divide it by 0. This is going to cause an error, which we are going to catch. Closing bracket right there. And then down here, we will say catch, and the error is going to be passed inside of here. We can print the error rather than have the program completely crash and look terrible. And let's say also that we always want to do a certain thing whenever our program crashes like this. For example, you might be working with a database and you want to close the database or something like that. Well, if there's code that always executes, you put it inside of finally, and guess what? It'll execute. Okay, so now if we run this, right, this, 0 divide infinity, right, like that, and then you also see I always execute, which comes from right here. So this is the name of the error, that you tried to divide by 0 and you got an infinite value, and that is an error. That's a bad thing. But we handled it gracefully, gave them sort of a message rather than our program completely crashing. Well, you can also come in here and you can go and create your own exceptions. So what I want to do is come up inside or outside of main, and this guy is not going to return anything, and it is going to check age. So let's say we wanted to verify that a name or an age was valid. Well, we could pass it inside of here, and we could say if A is less than 1, we're going to say that it's not a valid age. And in this situation, we want to throw an exception. And a good way to do this is to use this default format exception. And then what we can do is come down inside of here and go and test it. So we're going to say try like this. And we're going to say that we want to define an age, which is going to be equal to 0. Well, that's not valid. And we're going to crash our own program here on purpose. I'm going to call check age like that, A1 like that, and then come down here, catch, and we are going to catch the exception that's going to be passed. Guess what the exception is? Format exception. We just threw it, all right? And then this is going to print it out. Print out that exception. Like this, like that, like this. And there you go. And run it. And you can see format exception comes out. One thing to finally be aware of is instead of catch E like this, you could also go and type in on and look for a specific exception. So one of them is integer division by 0 exception. Okay, so instead of catch E, you could type on integer division by 0 exception. Be very, very specific. And also, you could end that with catch and E, and also output that exception on the screen if you'd like. All right, so there you go, guys. A pretty thorough overview of Dart, and depending upon how popular this video is, that's going to determine how many videos I devote to teaching you how to program with Flutter. And like always, please leave your questions and comments down below. Otherwise, till next time.